Okay, so and my name is Eric Johnson. I'm a serverless developer advocate at AWS, and I love serverless. We've been talking about serverless quite a while. Over the last 3 weeks or 3 episodes, we've been talking about security and really monitoring and analytics on it, securing the front door. And today we're going to be talking about securing the back door of API Gateway and really what that looks like. We know that we've taken a lot of effort to lock down the front of our API Gateway, but what we want to do is look at the application behind the gateway and see what we can do to kind of help just make sure things are locked down. So let's we're going to kind of jump into this, and here we go. So over the last all the episodes, we've been building this application. It's a weather application. We started with it being open, and then we locked it down. And when we left last, this is where we ended. We had built this secure weather application that had, we dealt with cores, we dealt with AWS WAF, with IAM, doing policies, resource policies. Bob, last episode you showed us how to do a resource policy that allowed an external account to pipe in. But the question really comes down to, and we see this a lot, is what about behind the API gateway? How do we make sure that we're secure? And we're going to talk about a couple of scenarios today that we look at, but there's basically 3 things that we're going to talk about today. Number one, we're going to talk about looking at client certificate verification, right? And Bob's going to expand on that in a little bit of what that means. Number 2, we're going to talk about trust but verify, and that's an interesting statement in that look, we trust you, but we're going to verify who you are. And the last thing we're going to talk about is throttling and how do we use throttling to protect our back-end services. So let's jump in here. And I'm going to do a little talk through on this before we turn the code over. There will be some live code here, but I want to kind of get this idea about what client certificate verification means and what we're going to do. So what we're basically doing with this is we're saying, hey, are you my API gateway? Are you really the API gateway that I'm expecting to get this from? Are you the endpoint? And one of the common use cases we see this in legacy applications, if we have a legacy application that's maybe in a corporate data center, and we'll talk about a couple of workflows on this, but we see this a lot, and this is a pattern that I talk to customers about on how do I start the process of migrating my servers, but how do I introduce security to my servers when they're not on AWS, when maybe we're fronting it with an AWS API or the Amazon API gateway, but we want to make sure that that's secure. So what you're able to do is we can go, on the AWS cloud, we can spin up an API gateway and we can have it point to our traditional server. And Bob, feel free to jump in at any time here, even if it's to say, "Hey, you're wrong." I'm okay with that.
So I think perhaps just the thing to point out is that when we first launched the service, sort of the only way to sort of have that connection was over the public internet. So there was no mechanism. So we'll route to any HTTP endpoint that you tell us to, but ultimately the endpoint must be publicly routable.
Right, and so what that means is if it's public, someone else could be hitting that endpoint as well, right?
Correct. Yeah. So absolutely. So that if the point is that you're trying to put a facade on top of your legacy backend with API Gateway to add additional authentication and authorization as well as throttling, it doesn't do a lot of good if someone happens to be able to discover your backend server and be able to invoke it directly.
Exactly. Now, we have introduced some ways. There are some ways of securing that pipe, so to speak, in that you can do it through maybe an AWS Direct Connect or even an AWS VPN. But if you're going to do these, or even if you're not, there's also a way to verify that the request you're getting comes from the API gateway that you're expecting or the entity that you're expecting. And the way you can do that is with the certificate. You can generate a certificate on the API gateway, and then you can verify the certificate on the server. And Bob, do you want to? And I know you're going to show us an example, but kind of walk us through this, what this means.
Sure, yeah. So what we're using here is a technology called mutual TLS authentication. In API Gateway, we will create a certificate and a private key pair. We'll hold on to the private key. We give you the certificate materials, and then you install the certificate materials on your server. And then when you tell us that you want to use it, we will send any request to that backend server with that private key. And so then your server is able to validate that whether or not the request, which is going to be SSL encrypted, it has the correct certificate or the correct encrypted materials in order to encrypt that connection.
Okay. So what happens if it doesn't?
That's going to be up to the application or the server owner. So traditionally, you would just throw that connection on the floor. So you would actually, you would look at it as so think about it as for like a browser when you're like verifying the certificate, like Chrome or Firefox will display an error message saying that the certificate doesn't match. Now, obviously, the server can ignore that message and process the request, or it can just literally say that, like, nope, I actually really want to make sure that connection is the one that I said that I was going to use, and is using the certificates that I wanted to use, and just drop it on the floor.
Okay, all right, that makes sense. So you have control on what's going to happen with that.
Correct. Yeah.
Okay. All right, so one of the things we get is I've had the question asked, okay, what's the use case here? And we're going to stray a little bit from security, but I thought this might be kind of interesting to bring up. Well, we get the, okay, why would I point to traditional service in my corporate data center? And obviously, there's a lot of different use cases, but one of the common ones we see is, look, we're trying to migrate to serverless, or we're trying to migrate to modern application development, but we're not sure where to start. And so this is a great example of building in security in that migration pattern. And I'm going to talk you through a little bit of the pattern that we see here, and we say, okay, what's the use case? What are we trying to do? And again, this is a conversation that I have a lot, so I wanted to kind of walk through it here real quick. And this is the idea of a strangler pattern, or the idea of how do I move a traditional server into AWS, or move the application off traditional server into AWS while keeping it secure, so on and so forth. And so one of the things you're able to do, if you've ever heard of this pattern, it's a pretty common pattern, it's been around for a while, called the strangler pattern. And what it would look like, this is a very simple example, but what it would look like is you would have all your services pointing to your traditional server. But I don't know, is your machine muted? We're getting like email notes and stuff. So
I don't even have my email client up.
Okay,
so I'm not sure if
I don't know what's going on. So sorry for you listeners, but we're getting email somewhere here. So, but what you'd be able to do is because the beauty of API Gateway is you can route things based on, even down to resources and methods, right? So I can route based on a post, a get, a put, a delete, whatever. And I can also route based on a resource, like user, client, different things like that. So I could have a user post go to one place and a user get go to another. That's how much control you have here. And so what you would be able to do is, let's say you have these three services pointed at your traditional server, you could then start breaking them out on their own. So for instance, service one, you've kind of pulled that out, you've replicated it in a Lambda, and then unbeknownst to your users, you can have that point at a Lambda inside. Then you can work on service 2, where it's no longer pointing to the traditional server. It's also going in through here. And finally, service 3. Okay, so then what happens here is this. Okay, so then what you've got, and you'll notice we're not doing any kind of certificate here or anything anymore. Now, we were able to maintain that security between our API gateway and our on-premise or somewhere else server, but here, we don't need to do that. And Bob, kind of what I was thinking about, on a Lambda, and we'll talk about a little bit later on trust but verify, but when you look at how an API gateway fires a Lambda or invokes a Lambda, I was asking, we were talking about this earlier, we were kind of putting this together, is there a reason for a Lambda to verify the certificate, so to speak? And I don't know if you want to jump in there, but I have some thoughts on this. What do you think?
Sure. Yeah. So for obviously for the for the Lambda function use case, like there's no certificate to verify, because you're not actually getting that information about the actual HTTP connection. So you're actually abstracted away. What you get inside of your Lambda function is an event context, which happens to describe the API gateway that invoked the function. Okay. Now, that's not to say that you can't do some verification on that to ensure that it is, in fact, API gateway that is sending that request, and that the right API gateway and the right information is coming in as well. But from a certificate standpoint, you wouldn't obviously be doing that because you wouldn't have that exposure. You wouldn't have that access to that information.
Yeah, so and that's a great segue into the trust but verify we're going to talk about in a few minutes. But when we go back to this, if you think about the way Amazon, if you think about the way Lambda is invoked, AWS Lambda. So when you invoke a Lambda, be it, we talk about asynchronously or polling or synchronously, but any service inside of Amazon invokes a Lambda through the Lambda API. Okay, privately, right? I mean, so it's hitting it directly. And so when API Gateway calls a Lambda or invokes a Lambda, it's doing it through the Lambda API, and you can wrap that with IAM, Identity and Access Management, and say, hey, only this API Gateway has the right to invoke this Lambda. So instead of verifying a certificate to say, hey, let's make sure it's the right person, instead you're saying, hey, I'm not worried because only this person can invoke this Lambda. Does that make sense?
Yeah, so the one thing to probably call out there is that those permissions are asserted based on the resource policy on the Lambda function. And I believe those will only apply if you're not using the invoke role for actually invoking the Lambda function from API Gateway. If you configure the API Gateway integration directly from the console, you'll get a prompt when you configure the Lambda function that says you're adding permissions to allow API Gateway to invoke the function. That's because API Gateway is using its own credentials to actually invoke the function on your behalf. And when we write that policy out, we ensure that the policy is written sort of at the least privileges. So literally the integration, the method, the resource is the only thing that's allowed to invoke that function when we add that permission. But if you configure a role for us to assume before we then call the Lambda function, then I believe those permissions would not necessarily apply because or they could apply, but you're left up to your own devices on how you actually configure the resource policy. But if you're configuring it via the console or via the tools that we've set up, like SAM, for instance, then the sort of the least privileges permission gets propagated.
Right. Okay. Yeah. And for those of you watching, if you haven't figured it out, Bob brings the brains, I bring the pretty. So, it's really, and sometimes the funny, but yeah, Bob, I appreciate you clarifying on that, and that helps a lot. So let's take this kind of one step further. When we're looking at this client verification, a lot of times we have people say, what if my quote legacy app is on AWS, or what if it's a modern app? You know what I mean? But we're not running it serverless, we're running server full, and as much as I love service, that's also okay, So let's take a look at that. So when we're talking about this, we're going to use a standard kind of application setup where we're fronting EC2, Amazon EC2, with Amazon API Gateway. Now, it's not quite this simple. This is kind of an overview, and I am calling this a legacy app, but again, this doesn't necessarily have to be a legacy app. But what in reality, when we're talking security, we're building an application like this, what it would really look like is something like this. And one of the things when you're looking at this, different from not different. I mean, we're doing security. That's our number one thing. But it looks a little different than when I'm running Lambda because a lot of security is inherited. When we build an EC2 farm or instance setup here behind API Gateway, there's a couple things that we want to do. First of all, it has to be in a VPC. That's if you're an EC2 instance, you want that in a VPC, and you want it in a private subnet. And that's just a best practice. Unless there's absolutely, a really good reason to put it in a public subnet. You want your instance to run in a private subnet. That helps with security. And then you see we've got security groups and we've got auto-scaling groups. And so the idea here is that as the Amazon gateway is routing data, it's then load balanced across multiple instances, multiple availability zones. Okay, and so what you've got here is an application that's scaling and is in multiple availability zones, so it's redundant, it's reliable, different things like that. So, Bob, when we're setting this up, correct me if I'm wrong, you can't verify that cert. I can still create the cert at Amazon API Gateway, but I can't verify it at the NLB, right?
That's correct, yeah. And so NLB is the technology that you would want to use if you wanted to use the client certs or the VPC link technology, which is how we can sort of bridge into the customer's VPC. The NLB then gets tied to what we call a VPC link and API gateway, and then the traffic gets sent to the individual instances. The load balancers themselves, NLB, ELB, ALB, and application load balancer as well, none of those technologies have certificate verification built in. So the customer is still responsible for sort of that validation of the certificate, much as they would be for the traditional server.
Okay, that makes sense. So what you'd be looking at then is with an NLB is rather than trying to grab that, you would just configure a TCP pass-through at the load balancer. And then at the instance, you would verify the cert, at the server level in your application or in the configuration like you would be in your configuration. Now, let me ask you this. We're going to see some demo code here shortly. Did you do a demo for every type of server there is?
No, and we're not going to be doing much in the way of doing configuration of the servers. I'll demonstrate some of the technologies here, but ultimately, like I could potentially show an example of a real primitive server like an Nginx. Right. But ultimately, like that, it's going to vary depending on the customer's configuration, the version of Nginx they might be running, or whatever software they're using, as well as their security profile. So obviously, we've been talking a lot about the certificates here, and it does add a certain level of security. But there are plenty of customers who have use cases that don't need that level of overhead and that level of security. Now, obviously, if you're in a compliance regime, most likely you're going to be forced into that. But if you're running an application that doesn't necessarily have the same level of security compliance concerns, you can even consider not even doing TLS at all once you're going through the API gateway to the NLB over the VPC, because that is already a protected channel. But obviously, apply whatever level of security and scrutiny that your compliance regimes and your companies are going to require you to.
Yeah, and that makes sense. I think, and I agree with you. It depends on where you are and what you think security-wise you need. But it seems to me this probably makes most sense, or at least if you're fronting through the public internet, an off-site something. If your traffic crosses the public internet, then I would be looking at verifying the server. Oh
yeah, no, absolutely. So so if you're talking about a public endpoint, then absolutely, I would 100% recommend doing the client certificate stuff. But once you sort of enter into the world of sort of VPC link and some of the other stuff, or doing all of the traffic over a VPC, then you might want to think twice, or again, whatever compliance regime you need to comply with, obviously comply with.
Yeah, perfect. I agree. So what we're going to do now, and I did want to call out that we didn't try to give you an example of Nginx, Tomcat, ISS, Apache, all the other things, but we're going to talk conceptually, and Bob's going to show some things conceptually about what this looks like as we climb in. So Bob, I'm going to turn it over to you if you're ready.
Sure. Let's go ahead and get started.
All right. Show me some code.
Okay, so first, let's just take a look at some of the stuff that we have available inside of the console. So we'll talk through some of the things that we mentioned briefly here. So the first thing is that our client certificates. So this is what I was mentioning, where we were mentioning before, that we can generate a client certificate within API Gateway. And so, unfortunately, this is not an ACM managed cert. It is a cert that is managed inside of API Gateway. So you create those on demand. And then you have this nice little tab here that allows me to copy the information out from the certificate. So then if I take that over to my text editor, I can very quickly get the certificate materials. And then I would install this on my server to then validate any incoming requests. Once I have the client certificate, that's only the half of the configuration. I then have to go over to my API and actually configure the API stage to use that certificate. So this is a field or a parameter that is set on an individual stage. So if I go to my prod stage and I scroll down here, I can see that there's this client certificate field here, which is currently set to none. And if I wanted to use the client certificate, then I would select it. Now for this API, it's 100% serverless, so it's communicating with Lambda. So it wouldn't actually do anything for this API. But if I had an HTTP endpoint that I was using as part of this API, then if I clicked this, if I selected this and then saved the settings, then immediately API Gateway would start sending requests with that private key that we created in our service to send those requests. So that's the client certificates. So then inside of Lambda, we have, again, other information that we can look at and trust and verify while we're verifying other things. And so we have our weather app here that that Eric had built and sort of talked a little bit about how he built through the Amplify console. And it's basically the same app as we had from the previous episode, but we have this new little button here, which is just a little bit of debugging information. So if before I log in, I click on this button, I get some text that is in different API endpoint or a different method on my API, which is returning back the sort of the authorization bits. So there are two fields here: the API Gateway Identity, which is going to map to the request context.identity field in the Lambda proxy. And so we have a whole bunch of fields here that identify my source IP, my user agent. And then not a lot else because I'm not authenticated here. I haven't actually authenticated with the service. So I'll go ahead and do a login now. And so now I've logged in again. And so if I go ahead and click on this information again, now you'll notice that there's not a lot more information in the identity. So the source IP is still the same, user agent is still the same, but none of these other fields are really filled in with anything. So these fields are really only valuable or really only populated when you're using AWS IAM authentication. So these are the built-in fields that we will give you when you authenticate a request using Signature version 4. On the other hand, though, this API Gateway Authorizer, which again is the API, the request context.authorizer subfield of the proxy response, I have a whole bunch more information here. And so I can see there's a whole subsection or whole dictionary here called claims. And so those are the claims that are actually attached to my Cognito user pool identifier. So because we're passing in the identity token to the API, I can see all of that information about like my email address, the actual username, the user identifier inside of Cognito that applies to my user, as well as the audience field and sort of the issuer. So these are fields that you could validate and ensure that like there hadn't been a misconfiguration with your API. So if you're including the information about your Cognito user pool in your application, then you know which Cognito user pool your user actually authenticated with, and you can validate that. So again, so it's the trust but verify. So we configured Cognito identity or Cognito user pools as an authorizer on my API, but I can still, inside of my Lambda code, assert and make sure that these values are provided and correct. And so if they aren't, then I can throw an error and I can and appropriately log a response.
Something else that I'll jump in here that I've seen as well when using like sub. So sub is a unique identifier of the user, right?
Mm-hmm.
Okay. So when we use sub, I've seen people use this for like a hash in DynamoDB. And then you have a quick way of quickly identifying a user in DynamoDB. So this is, I mean, obviously authorization and trust but verify, but it goes beyond and be able to kind of keep this data in sync as well with this.
Yeah, absolutely. And you obviously, with Cognito, you can actually add additional claims to users, so custom claims. And any custom claims that you add to the user in the that get baked into the identity token will show up here as well. They'll be available inside of the API context.
Cool.
So that was obviously Cognito, and that was obviously the focus of what we were doing for configuring the API in the previous episodes. But I also have here a couple endpoints that are using a different authentication mechanisms, just so you can see sort of what the results are for that as well. So here is an IAM authenticated endpoint, and so now you can see that this authorizer field is basically empty. But now we actually have some data inside of the identity context. So that's the account ID of the caller. So that would be useful if you're allowing for cross-account access. Again, you might set up a policy on your API, like we did in the previous episode, to allow another account to call in. But you still might want to just assert that only the accounts that you've actually verified and added are ones that you are allowing in. So we can also see the full user ARN. So I'm using IAM user credentials here. If you were using role-based credentials, you would get the role access ARN here. And so then again, we also have our user agent, etc. So these Cognito fields in here may be a little bit misleading. So I mentioned before that everything in this identity block is only supplied when we're using IAM-based credentials. So the access key, secret key, session token, so the SIG-v4 signature. When you're using user pools and you're using the access token or the identity token, there's obviously no signature there. So there's so none of these fields would be populated. But if you're using the Cognito federated access, where you can supply a role and get credentials based on that role for your user, then when you sign the request with those credentials, you would get fields populated. So you would get your Cognito authorization type, which would be, if you're using straight up just Cognito user pools, that would be Cognito IDP. Potentially you could also use Facebook, Google, log in with Amazon as additional providers, or a generic OIDC provider. Your actual provider would show up here as well. And then the identity ID, if you were using explicitly Cognito federated identity, then the identity ID and the identity pool ID would show up there as well.
Okay, I'm gonna call a timeout here for a second. So let's talk about that for a moment, because I know the first time I heard, and I understood what you're saying, but the first time I heard all that, I was like, what? So when we talk about authenticating with Cognito, and again, Bob, jump in at any point, and even to say, whoa, you're wrong. But when we talk about authentication with Cognito, there's several ways to do it. When we go back, and Bob, I'm going to take over screen sharing again, if you're all right.
Sure,
with that.
absolutely.
Okay. So I want to go back to our... hang on a second here. Kill that. Back to my deck. Bear with me, guys. It's giving me grief here. All right. So when we go back to our architecture that we built, and I'm going to go back to slide number 3 here. So we did several of these authentications. Number one, the one we didn't use is the federated ID, which is one he was talking about. But we did use the user pools. So if you remember when Bob logged in, it took him over to a Cognito authentication. You logged in, and it came back. And so what user pools provide you with the ability to do is you have username, password authentication, and then you can also set up user groups, okay, that can be used to kind of, hey, they have this kind of power, that kind of thing. The second thing you have is an IAM authorizer, which is the signed authorizer coming. That's like when we're coming across account, right? So we're using an IAM authorizer from the other account, and that had the SIG-v4 signature that had the information in it. Okay. The other thing we were talking about is the federated identity, or that you can do through Cognito. And what that is, so when you go to Cognito, you have two different kind of pools that it kind of talks about. One is user pools, managed user pools, and one is federated pools. Is that what it's called?
They're called identity pools. But it's that the product's called Cognito Federated Identity, I believe.
Right, there you go. Thank you. And so what it allows you to do is tie together Facebook and different, whatever, different products are out there. Open. Tell me some of the ones it ties together, Bob.
It supports. I used to work on the product. That was before I worked on API Gateway. So it supports Facebook, Google, login with Amazon. I believe it still supports Twitter and OpenID, any generic OpenID Connect provider.
And then can you then tie that to like a user pool ID as well?
So there's you can So this is where it gets tricky.
And if you want to go down this road, that's okay. But
it's a little bit of a nuance here. So Cognito identity pools are a mechanism for sort of federating access into AWS. But then there is also are also federation mechanisms for linking external identities to a user pool identity, and those are distinct. That's something that for better or for worse, the Cognito team decided to split out from that. So there's the identity pools, which you can think about as just strictly federated access into AWS resources, and then there's federated or linking an existing user pool user to an external identity. And so those are two different things. That being said, Cognito user pools does support federation into AWS, so you can associate a role to your Cognito user pool and get credentials based on that role, which is what I was referring to before.
Okay, great. And I just want, I don't know if that cleared it up, and I'm thinking we might need to do another show on that, just to talk about Cognito and how that's done. But I kind of wanted to explain that, because the first time I approached it was a little confusing. So we want to make sure that that we understand what we're talking about in user pools versus federated IDs and all that kind of stuff. So hopefully that's helped some. Now the other question I wanted to talk about, as we're talking about trust but verify. And I'm going to show us, again, go back to the screen here and kind of talk about what's going on. But I want to talk about where, the data that we got. You talked about different authorizers putting different data into context. But there's a little more to that. Not more, but another part I want to talk about is...
So, Eric, do you mind if I just show the one last example I had before we jump into that?
Please do. Jump in.
I'll just, before we jump into some of these details here, I just wanted to quickly show the last example, which was the custom authorizer. And so we talked very briefly about it in the previous episode, and we didn't show any code. But I configured a custom authorizer, which again, will have no fields in the identity section, because again, no SIG-v4 signature. But the authorization field will have additional fields in it. And so you'll notice here some interesting context and a custom auth value. Now you might be saying, it's like, where are those values coming from? They're actually coming from my Lambda function that I actually created. So you can pass back it has to be a flat dictionary, so no nested values, but you can do key value pairs and pass value from your custom authorizer into the context of API Gateway, and that's probably a good segue into what Eric is going to talk about with how you can pass that information around and how you can make it available.
Yeah, I wanted to comment on and really compliment you on your creativity as well and your names.
I've never been very good with names, code names or anything like that. None of that stuff is. So it's my variable names are that variable.
You're a developer at heart, so you can tell that I'm very creative if you look at our weather app and how creative that is. So, all right, let me bring back up our screen. So bringing the screen back up again, we're back to our weather application, and so one of the things we're doing is when we talk about that context data, it's getting added at the API gateway, right? And it's basically being added several different ways, as Bob talked about, whether it's an IAM authorizer or it's a user pool, or Cognito authorizer or a custom authorizer, so that context is getting added. But the other thing to look at is when we're talking to our Lambda, are we talking to it via proxy or are we talking to it as an integration? These are quotes, just so you know. And it's different. If you remember, we talked about this when we went back, I think, in episode 2. But I want to remind you again, you can create the context there, and we read the context data at the service level. But if we look at the different types, when we talk about a proxy request, talk about a proxy request, this is just kind of a refresher. When the request is made, API Gateway does a wrapper, and you get automatic context. You don't control that context. It's just, here's what you get, okay? But if you need more control than that, and this is an example, and I'm looking, that might be kind of dark to read. This is an example. This is not the full thing. This is what fits on a slide, but you saw more of it in our identity return. But this is kind of what's added. However, when you do an integration, and if you remember, that's different than a proxy in that you're doing a lot more at the API gateway level. You have the power of VTL to change that request. So the request comes in. You put it. API Gateway doesn't do anything on its own now. It's saying, hey, I'm going to let you model that request on how you need it. So you can build a body, you can build a context, you can build a Bob. If you want a Bob object or a dictionary, so whatever you want, but you control that through VTL and through the templating, and then what you get is really your choice. So again, as you're thinking about the context of how that works. It's important to know what we're doing. What authorizer am I using? So that's obviously is going to put where that goes in the context. If you're using a proxy, if you use an integration, then most of that information is available to you. You just have to grab it from the parameters and put your context together. So, anything you want to throw on that, Bob?
So the only thing probably to note there is you can start with sort of if you use the console, there is an example VTL template which sort of emulates sort of the same functionality as the proxy, and that's a great starting point for kind of like pulling out the pieces of information you need if you're using VTL.
Yeah, that's one of the first things I do, and if I'm building an integration, is I take the default and then work down from it, trim it out, because it automatically iterates through everything coming in and breaks it out for you. So,
and if you're kind of size conscious in terms of like the payload size being sent to the integration, then obviously you'd want to pare that down.
If you're looking at this kind of scratching your head a little bit, I encourage you to go back to episode 2. Because George Mao we talked through that, and we talked through an integration versus a proxy, and we actually show everything that we're talking about. So we have it on video, it's on YouTube, it's on Twitch, go take a look. All right, so the last thing, I think, you ready to talk about throttling?
Yeah, I think that was the last topic we wanted to talk about.
So when we talk about throttling, we're not really authorizing through throttling and things like that, but what we are doing is we're protecting our downstream services with throttling, right? And so as a refresher, just a little bit, we talked about throttling, we talked about this in episode 1, boy, a lot of references today. We talk about, throttling allows you to break down how many times concurrency can people hit your API, right? So you're looking at it can be done on a per client, per method. It can be done in per client, separately per method, and per account. And so those kind of layer as you build it up, and you can create usage plans and hand it out to different folks. So you have a lot of control over how hard your API gateway is going to get pounded, and so you can see how this would kind of protect downstream. And Bob, you've got some examples on showing this?
Some
stuff you were going to talk about, sorry?
Yeah, well, so we can talk a little bit through. I don't necessarily have a built example for this, but
no, that's fine.
The important thing to note there is that like that you can think about that per method throttling. At the stage level, not sort of the blue box that we've got here in our diagram here, as sort of the thing that protects your backend. We can think about it as like, when we were talking about the strangler pattern earlier, if we've got like a certain number of methods or a certain number of resources that are mapped to a legacy backend, we can set a per method throttling rate on that stage to say that like our server has only been rated for 1,000 RPS. Let's say it's an old clunky system for whatever reason. It's not that.
What is RPS?
Request per second.
It seems obvious, but it's not always obvious. So I want to make sure.
Fair enough. Yeah, so it's literally only been rated for about 1,000 requests per second. So we'll set that as the sort of the per method throttling rate that we will do on that method. And again, that's global for all callers of the API of that method for that API, and that's literally just to kind of protect that legacy backend. Now. Once you do that, now obviously you've got a problem where a single caller could potentially use up all of that rate, that back-end rate, by calling your API over and over again. And so that's where your usage plan per client and per method per client call rates will come into play. So you can set a usage plan rate that will be much lower, so that each individual user only gets a very small slice of that per method limit, and so then you're preventing any one single customer from overwhelming your legacy backend. Now, obviously, you can use that usage plan to also just prevent customers from hammering your API in general anyway, and that's generally a really good practice. So the thing to kind of note there is that so usage plans are tied to API keys, and so currently today there is a hard limit on or a limit on the number of API keys that you can actually manage. So that is still going to get limited basically on an application developer level rather than an individual logged in user level. So currently today we don't support limits on sort of like a limit per authenticated user to Cognito as a for instance. Okay. So you're still going to be setting that limit at sort of an application layer. And so there are two ways that you can pass today the API key. One is baked into the actual request, so as an X API key header, where you actually pass that key value through. But if you're using the custom authorizer, we actually allow you to set up the API key source. And if you want, I can switch over to take over and show that at least in the console experience.
Yeah, that'd be great.
Yeah, so if I switch back over to the API gateway, so this is a setting that you would set at the API level. You have here this API key source, and so by default it's header because that was what was available when we first launched. But you also can specify that the authorizer is actually going to supply the API key. So that means that your customers don't necessarily need to know about your API keys, but you can still assert and associate classes of users or individual users into a bucket or into an API key. So while you can't necessarily get per caller throttling rates that way, it is a good way to sort of segregate some of your users. So I mean, again, if you were trying to emulate the model that we had with our weather app, where you had a premium class of user and a non-premium class of user, you could associate different API keys for those different classes of users. And then if you had sort of a top tier premium user, then you might even say that they get their own API key. But because of the limited number of those, that would be something that you would probably want to have a strict cross control associated with. And so then once you do that, then you can configure your usage plans and your API keys to set the control rates for both throttling and quota. So it's probably a good place to sort of have a quick discussion about sort of how API Gateway does throttling. So we use, much like most AWS services, we use what's called a token bucket algorithm. So the way you describe that is that you think about your availability of calls as the bucket, and then we are literally adding tokens that at the continuous rate of X number of requests per second. So it is not on a second boundary. So it's literally a continuous. Think about it as a spout, where it's literally the requests are filling up this bucket over time. And then you can reach in as a caller and take a token out of that bucket. And then eventually the bucket will fill up and start overflowing and won't receive any more requests. And that's what we can call the burst. So the burst level is the size of the bucket. The rate is the rate at which the bucket fills, and then you're taking tokens out. So if you don't have the ability to take a token out of the bucket because it's completely empty, then you get a 429 response back, and you'll have to try again later after a token has been added to that bucket again. And again, just to be again real specific or maybe a little bit pedantic, it's not on a second boundary. So you don't think about the context of like your default rate is 10,000 requests per second. That does not mean that like if you make 10,000 requests, you have to wait a second before you start making requests again. That bucket will refill over the course of that 1 second, and you can start continuing to make requests.
Okay, that makes sense. So let me ask you this, or let's talk to this in when we're talking about protecting our downstream, right? So we're talking. Okay, so we're going to throttle, but let's say some of the questions we've gotten and things that we hit is let's say we've got a denial of service going on, right?
Sure.
So we're just getting hammered. So if we're at, let's say we have 1,000, so we're still getting shut down, right? If now our downstream is being protected, but we're getting blocked, right? Now, Amazon's got things in place to help protect against that automatic. For this scenario, one of the things is in this how critical are metrics in this and alerts is what I'm driving at.
Sure.
So if you want to jump on that, or I can continue either way.
Yeah, so the thing to kind of like note there is when we were showing the dashboard before, so the dashboard that we had set up, which I don't think was in this account actually, but if I go to the built-in dashboard that's on the API Gateway console, I can see sort of the calls here. And so anything that falls into the throttling category would be in this 4xx errors. So if you're seeing a lot of 4xx errors, that means that you're getting potentially 429s or throttle responses. And if you wanted to get sort of more specific there, then you would want to configure the access logs to actually see the call pattern there. So if you could quickly set up an insights query to see throttled IPs or throttled customers that are generating the higher number of requests. And then you can either decide to take the sort of very aggressive approach if it's like coming from a single IP and setting up a WAF rule to block that IP address at the very front end. So like before it even gets into the throttled requests, like you're just literally shutting that customer off because they're affecting you too aggressively. If you're doing something like the API key stuff that I was talking about before, you could, or doing the custom authorization, you could say that like that user is now no longer, allowed to call at such a high rate. You could change them to a plan that had a much lower rate, or stop allowing them to authenticate altogether. So either one of those things would prevent your API from incurring, and your backend from incurring those requests and being overloaded.
Okay, and that's what I wanted to drive at is you can do this, the throttling, and help protect that, but there's remediation you can take as well. We had a question earlier, and how do I how do I block a flooding and stuff? And yes, WAF is a very viable product for that. So, well, I'll tell you what, we're about to wrap up. I'm gonna take back over unless you've got something else to show here.
No, go for it, man.
Okay. All right. So today, obviously, we've been talking about protecting, the back door, shutting the back door. Last episode, we talked about shutting the front door. And before that, we talked about metrics and alarms and alerts and different things like that. If you missed any of these, I really encourage you to go back, because as we were talking about, Bob was just talking about doing an insights report. What does that mean? If you go back 2 episodes to episode 3, he can walk you through that, and we show the code on how to do that. So we are going to be taking a little bit of break for the rest of July, just because I'm sorry, today this is June. Look at that, my months are all crazy. Our next episode is going to be Look Ma, No Compute. One of the questions we had on our Twitch channel was, hey, can I use, I want API Gateway, but we're not ready to go serverless yet. Well, that's okay. API Gateway, like we said earlier, can front any public API endpoint or endpoints inside of AWS that aren't public. We showed some examples of that, and yes, even ECS. You can put it in front of ECS, put it in front of Fargate as well. So you can get crazy with containers. But what we're going to talk about is. And my guest wants to be Randall Hunt. He's one of our senior technical evangelists. Brilliant guy, a lot of fun. We're going to be talking about what does API Gateway look like without a Lambda behind it. So we're kind of getting into this idea of, hey, does it have to be Lambda? No, it doesn't. Lambda is just one of the many tools that you can use with API Gateway. API Gateway with the VTL, with the ability to model your data, or the ability to modify your request and your responses. You can do things like connect directly with DynamoDB or Amazon S3 or Amazon SQS. And so we'll talk about that and how do you do your handling or your error handling at the API Gateway level. So a lot of power there. I encourage you. This is going to be on July 9th. So we're about almost a month away. And we'll start up our regular cadence again. And thank you for joining us. This is Bob and I'm EDJ Geek. And he is Tarakma. I know I don't say that right, but we're going to go with that. He doesn't say it right either, so, I mean, come on. But guys, we appreciate you following or watching us and following us. I encourage you to follow us on Twitter. We talk about serverless a lot and other things. Again, good with the bad. So, Bob, you have anything you want to say before we go?
No, it's been a pleasure working with Eric on these episodes, and I will also be taking a slightly, obviously, longer respite, but I'll be back for some of the later episodes in the series.
That's right. In a couple of episodes, we're doing one called Ask the Experts, and we're all just going to sit in a room, and it's going to be like Stump the Chump. So Bob will be with us, and he may be the chump, I may be the chump. We'll see. But we encourage you, if you have tough questions, man, send them to me. Again, you can DM me at EDJ Geek, or my email is ericdj@amazon.com. With that, we are out. I hope you have a great week. Thank you.
All right, thanks.